One thing that we see, pretty broadly, and this is not a new story across the service provider industry, is that there's this squeeze underway with traffic growth on one side of that, continuous new investment in infrastructure to keep up with the huge increase in services delivered across the network, especially video. And on the other side of that is competition. Some of that competition is from traditional competitors, peers who are also service providers, but more and more the competition comes from third parties, from OTT services across the network, who kind of have the double whammy of accelerating that traffic growth and also potentially stealing subscribers away from traditional offerings like pay TV or landline voice type of customers. And that has a negative effect on both cost and revenue and makes the situation from a business perspective very challenging in this environment. Those threats are accelerating. So in the pay TV example, there's a dramatic year-over-year increase in subscriber churn, as well as a dramatic increase in the number of customers and the volume of data being delivered by those OTT services. And this is just one example. We see on the enterprise side things like SD-WAN offerings increasing traffic and stealing subscribers or customers away from traditional MPLS-based offerings. So one thing we think a lot about here at Kentik is how network data can help counteract some of those negative trends that are affecting profitability for service providers. The issue, though, is that the traditional ways that network data have been handled are pretty broken. They were really built for a time when networks were much smaller, when the volume of data coming off of the network was something that could be handled, in traditional monolithic application architecture, either appliances or software that ran on single servers. And what's really needed today is systems that are not just accepting and aggregating data, but systems that are oriented around big data concepts. So retaining a large volume of unaggregated data and allowing users to explore rather than just report on the data. Many times the questions at hand are not questions that were anticipated ahead of time. So if you have a system that is aggregating and throwing away the input data, you're not going to be able to answer the questions that arise in the moment, because through that aggregation process, you've lost the details that you need. And so what we're really talking about here is building analytics platforms the same way that every other modern application is built, which is to say, using distributed systems, column store databases, horizontally scalable architecture, so that as the analytics workloads grow, as the volume of data grows, there is a scalable way to handle that new load and still provide the same granularity, the same responsiveness of the system. For a lot of these questions, especially real-time operational questions, we can't wait for a Hadoop-style system to process all of that data and deliver an answer an hour later or several hours later, or in some cases days later. That's not workable for the type of questions that need to be answered. So if you have a modern system like that in place, there's a lot of use cases that can help restore that competitive edge on both the cost and the revenue side. So on the cost side, we see providers making more efficient decisions about how to grow their network, who to interconnect with, capacity planning processes that are automated rather than via spreadsheets and a lot of human effort, understanding how subscribers interact with the network and using that to make data-driven decisions about who to partner with, how to price and package offerings based on how subscribers actually use the network. On the revenue side, we see providers using network data to understand opportunities to sell to new customers, to build pricing or packaging plans that are more profitable, and to actually take data that is collected for the provider's own operational purposes and present that to end customers or subscribers as a value add or even a revenue generating service. And then we can also use the data for operations purposes, for service assurance, for managing performance, and for network defense. So there's really 3 steps here. The first is identifying the data that's available and how that can be acquired. And there's a variety of data sources that come into play here, and we'll talk about that in a second. The second is about enriching and fusing the data. So in many cases, the native data sources don't have the right context. It's very difficult to use IP addresses as identifiers. We need to add on to the network data some business context, so that instead of looking at traffic flows between IP addresses, we're looking at customer IDs or sales regions or physical locations within the network. And then once we have a robust data set, we can use it to ask questions of the data that really help us understand opportunities to save costs, improve customer experience, or generate more revenue. From a data collection perspective, we think about 2 domains here, and these are kind of separated in the top 3 and bottom 3 items in the visualization here. On the bottom 3, we have traffic metadata. At the lowest level, that could be packet data, although in large networks we see packet data being used sparingly because it's very costly to look at raw packets in large networks. But in some cases that can make sense if it's critical resources where there's no other way to get the data. The primary input that we see from a traffic perspective, though, is flow data. And there's different flavors from different vendors, SFlow, NetFlow, IPFix. And flow data is great because it gives us a lot of detail about the traffic on the network, and it allows us to leverage the existing investment in network hardware, because every type of modern network hardware is capable of producing flow data. It's built in, and that's true across both physical and virtual network hardware these days. On the application side, we can also get data from modern application architectures like Kubernetes, NSX, ACI, Istio service meshes, and that applies more in data center environments where applications are being hosted. The other side of the data collection is context data. So that could be threat feeds for security purposes. It could be network structure data, like network topology, geolocation data, BGP routing data, DNS and DHCP data that allows us to associate subscriber IDs or subscriber class with traffic flows. And then on the top level, from a business context perspective, we're talking about things that are really meaningful widely across the business, like usernames, customer IDs in an enterprise environment, cost information. So how much does this link cost versus this link? And so we can kind of crunch all these together to produce a really rich data set that becomes very useful for answering the type of questions we've been talking about. Data enrichment is about associating those different sources of data with each other to produce what we think of as a universal data record. So there's a lot of systems that do post-processing on the data where we store all of these data sets separately and then run a correlation or an aggregation process on them post hoc. And the issue with that approach is that it makes the system not real time, right? Because typically it takes a fair amount of time to crunch all that data. And I don't typically have the full fidelity or the full dimensionality of that data to use real time. So we think in order to get the most value out of the data, to be able to explore it, run large queries that return results in seconds, not minutes or hours, we need to do that data enrichment, those joins, if you will, real time as the data is ingested. So doing all of this correlation as the data is received, and then storing a single record that is fully annotated or labeled with all of that context, and then it becomes instantly usable for producing insights. We see, and this kind of harkens back to the survey results, but building this kind of system in-house is harder than it looks because it requires a confluence of a huge number of disciplines, from folks who understand network protocols, SREs or DevOps folks who can keep a large distributed system up and running, network engineers who actually understand the type of questions that are going to be asked of this, folks who can build reliable and performant distributed systems, and then a fair amount of talent on UX and UI design, because for this data to be really usable, we want an interface to it that is usable by a broad set of teams who can get value out of this data. In many cases, we see that there's a data science team who understands how to interact with the data, and they have to handle the queries or the questions that come from other teams, and so there's a lag because there's an intermediate party who can interact with the data, and the people who really need to ask the questions are one step removed from it. So the Kentik platform was explicitly designed to fill this gap in the market for large-scale performant network analytics that can answer these questions real time and provide broad set of value to different stakeholders in the organization. The platform is a horizontally scalable distributed computing platform that can accept flow data, business context data, geolocation data. Some of these data sets are things that are built into the platform. Some are things that customers add based on internal data sets, so associations between customer IDs and actual network traffic data. And then the output of that is both kind of a streaming-based analytics, so we can detect changes in network traffic that might be relevant across planning, anomaly detection, those sorts of things, but also a real-time ad hoc investigative component so that we can ask questions of the network traffic to answer things that we need to understand for planning or getting these monetizing insights out of the data. Kentik's also an API-first platform, so we have a large number of built-in integrations with systems that might drive automation, but there's also the ability to integrate with custom in-house platforms that you may have deployed already. In the next set of slides here, I want to dive into some specific cases that our customers are using the Kentik platform for. And some of these use cases are more oriented toward wholesale or enterprise type providers, and some of them are oriented more towards retail or consumer type of providers. So the first ones we'll talk about are about generating revenue from network traffic. So one opportunity is to understand where traffic flows beyond the edge of your network, beyond your network boundary, and identify opportunities to sell to customers who are not already directly connected to your network. So the diagram we're looking at here is looking at traffic by physical location or POP, and the type of connectivity out of that POP. So some of these are free interconnection with other providers. Some of it might be paid IP transit. Some of it might be paid interconnect where we're only delivering traffic to that network. The third column is the actual entity that we are directly connected to at the edge of our network. And typically, that would be a peer or someone that we agree to exchange traffic with without compensation or remuneration because that traffic exchange is beneficial for both parties. Sometimes it might be a paid provider, sometimes it might be a competitor. Beyond those direct connections, though, are people that we could potentially sell to because they are receiving a large quantity of traffic from our network indirectly. They're probably paying this intermediate party to receive that traffic. So these are entities that a sales team could approach and say, hey, we see you're receiving or sending us this amount of traffic. If you bought some connectivity from us directly, we can give you a better price and also better performance because we're eliminating middle hops. So we have a large number of wholesale carriers who use this type of sales prospecting extensively and even give sales managers direct access to the Kentik platform with a curated data set that's especially useful for this type of analysis. There's also the possibility of looking at specific enterprise-type customers to understand which services they utilize, especially third-party services, so that we can upsell them in-house alternatives. If we see them using third-party backup services, we could upsell an in-house backup service, or a third-party VoIP or telephony service, we could upsell an in-house service and create bundles that provide more value for those customers. The other related use case is understanding how individual customers utilize the network. So if I have a customer where, let's say, I receive their traffic in Seattle and I deliver some portion of that to peers or other customers out of that same POP or physical location, that traffic costs me a lot less to deliver than a traffic that I have to backhaul across my backbone, either domestically or especially internationally. So if I can look at how that customer is utilizing the network, I can tailor the pricing based on per customer cost rather than using a blended COGS model for pricing my services. And that really gives me a leg up on competing with other providers because I know exactly how this customer is going to cost. And the other thing I can see is if I'm receiving traffic from this customer and I deliver that traffic primarily to other customers, that's really the best scenario because I'm monetizing that traffic both on the receiving side and the delivery side. And so that can play into the price that I offer to individual customers and incent them to be efficient about how they send traffic to me. Another opportunity to generate revenue or alternately increase value or stickiness is to take the network data that we collect for internal uses and actually present it back to downstream customers as in an analytics portal. So the Kentik platform actually has built in a white label portal capability that I can customize with my own branding and logo and create curated data sets for enterprise type customers to help them understand how they're utilizing the services that we sell to them and give them self-service access to really common questions like top talkers, top applications, and allow them to troubleshoot their own congestion issues or to verify with data the invoices or bills they're being receiving. So if they've got an overage on a commit that they bought, they can log in themselves and see, oh yeah, that was because this application was generating a lot of traffic or these users were engaging in this activity. And so it can reduce customer support and billing support caseload by providing that self-service capability. On the customer experience side, there's a huge opportunity to use real-time network data for troubleshooting, for reducing the time it takes to resolve incidents. And the capability that's really unique in the Kentik platform is that fast query capability. So being able to ask questions and get answers in seconds. Oftentimes we see that a troubleshooting scenario involves looking at data in one way and then drilling down maybe 1, 2, 3 times before I get the answer that I really need to figure out what the root cause is or resolve the problem. And if each of those steps takes minutes or hours to get the granular data that I need to see what's really happening, it is not really a useful platform for operational purposes. So we see this as a capability that's utilized across every customer that Kentik has. We also can use that same data to proactively detect service impacting incidents by profiling normal traffic distribution along some set of dimensions. So what is the usual distribution of geographies that I see coming across the network or from this customer? Who are the usual top talkers? Who are the usual destination geographies that I deliver traffic out of? And so that allows us to proactively detect both malicious incidents like DDoS attacks, but also things that are not malicious like misconfigurations or changes that third parties have made about how they're delivering traffic into our network, and to detect and resolve those incidents before customers notice and start complaining about that. On the DDoS side specifically, we have some built-in automation capability for injecting routes, RTBH or flow spec type of routes, to block traffic that might be malicious. We also integrate directly with some hardware DDoS mitigation platforms from A10 and Radware. And then we have a very robust API for driving custom automation integrations. So we have quite a few customers who use that capability. Some of them have built automated traffic engineering capability on top of our platform. So speaking of traffic engineering, on the network cost side, we have the capability to understand how traffic is flowing through the network and make network architecture or network routing policy decisions to optimize traffic flows for better cost. So this is a diagram looking at a example POP in Chicago, seeing how traffic comes into that POP, some of it from our backbone from all of these other sites, some of it from a neutral peering exchange where we exchange traffic with other providers. And then we can see where the traffic goes beyond our Chicago POP. It goes to these other POPs, and then out of those POPs it goes to customers or to another peering exchange or to a private interconnection. So let's say, for example, the connectivity between my New York POP and my Chicago POP is approaching capacity. The simple answer would be just to increase the capacity on that link. Let's add another 10G wave between those POPs, or 100G, or whatever it is in the scale of a given network. But if I can see that large majority of that traffic is actually going from New York through Chicago and then onward to San Jose, maybe it makes more sense to provision new connectivity between New York and San Jose directly so that that traffic bypasses the Chicago POP. That would have the effect of resolving the capacity issue on New York to Chicago and provide a lower latency connection directly between New York and San Jose. And so there's probably 10 or 15 different ways that customers are using our platform to understand at a detailed level how traffic flows through the network to make these types of traffic engineering decisions. Another cost-saving option for especially mobile carriers or providers that are more consumer-oriented is to understand where traffic comes from a traffic ownership perspective and a delivery infrastructure perspective. So which CDNs are delivering traffic to my subscribers, and what services does that traffic actually belong to? And we do this using a technology called True Origin that merges traffic volume data with DNS resolution data to identify the service type and the service name, and also a map that allows us to map those DNS names to the originating service and service type. This gives providers a insight into which OTT services are generating the most traffic towards subscribers, which CDNs those OTT services are originating from, and they can make better decisions about how to receive and deliver that traffic at the lowest cost. They can gain competitive intelligence about OTT services that are competing with in-house services, look at how many subscribers on average or at peak time are utilizing those services, and negotiate with those third parties armed with real data. So this is something that both architecture and engineering people find useful, but also product entities within provider organizations, so that they can potentially make partnership deals or pricing and packaging decisions that take into account how customers or subscribers are actually utilizing these services. This is an example looking at video traffic across a network. We can see a large volume of traffic being delivered from Netflix, and this is really optimized because it's being delivered primarily from on-net caches, and the same for YouTube traffic. But then if we look at traffic coming from Hulu, some of that is coming across free interconnection with CDNs like Edgecast and Fastly. Hulu utilizes a wide variety of CDNs. But a lot of the Hulu traffic is coming from level 3 across paid transit link. So this could be tens or hundreds of gigs of traffic depending on how big the network is. And this is a real opportunity to work with Hulu to move that traffic to delivery source that is a lot more cost efficient than receiving it over paid IP transit. And this is just one example with video, but there's n number of examples with other types of services where there's insight to be gained about cost optimization. Another use case for this type of tracking is to understand events that happen. So this was something that we saw on a real customer network when Fortnite Season 6 was released, and this customer saw a huge spike of traffic coming from a whole wide variety of CDNs. And because we were able to identify that traffic as gaming and associate it with this Fortnite release, it put them at ease that this was not a malicious event, but kind of a flash crowd scenario, and brought their attention to the fact that these big gaming releases were capable of generating traffic volume like this, and allowed them to modify their planning process to anticipate these type of events going forward and make connectivity decisions on that basis. And then the last use case I'll discuss here is subscriber behavior use case. So we have some customers, and this is sort of jurisdiction dependent, who want to tag traffic with individual subscriber IDs. And some of this is about finding abusers in the network or enforcing caps or fair usage policies. But it also helps customer service if they have a tool they can go into, customer calls and says, hey, I got billed for an overage, or I am experiencing poor or slow connectivity. The customer service agent can see traffic category over time on an individual subscriber basis. They can say, well, we see that you've been streaming a huge amount of video over the entire month, and so that's why you got billed for an overage, or that's likely what's causing the congestion on your link is this pattern of usage. And so it allows those customer service agents to provide a better quality of case resolution to provide that understanding to individual subscribers. And then if we can analyze usage trends across classes or categories of subscribers, that allows us to potentially build plans that address specific categories or types of usage. So you might build a plan that is more profitable for your top 5% of users in terms of traffic volume, and another plan that creates more profit for the usage patterns of the next 25th percentile and so forth. So to kind of summarize what we've been talking about for monetizing network data, a lot of this data is already data that service provider networks are generating or that they have available in existing internal systems. Identifying the data that's available and collecting that, correlating that is kind of the critical first step. And then with modern platforms with modern software architecture, we can get a lot more value out of that data than has traditionally been possible, and really use it to create a competitive advantage and yield more profit for the business.